We're going to play the find two numbers game. First one, that multiply to 24 and add to 11. Two numbers to do that. And then we're going to find two new numbers. That multiply to 6 and add to -5, and then go ahead and find two more numbers. Okay. So just see if you can't quickly find those pairs of numbers and get those going. Well, I don't even know if it's revisiting because it's the same three. I think now it's an automatic referral.
Thank you. That's fine.
Right?
I'm pretty much done too. That's why I was
Yeah.
this.
No, because they like, and I think it says on there if you're late again, it's just an automatic referral.
I got it. No problem.
Because I'm over that game.
Yep.
Yeah.
Because I gave my B card and he was about to have it calculated.
You'll be all right. You'll be all right.
Yeah, 106.
Hey, you'll be all right.
Can I get one with
24 and add to 11. 6 times 4 is 24. 6 plus 4? Chris. 6 plus 4 is 10. What? 8 times 3 is 24. 8 plus 3 is 11. It's all right, a valiant effort. Okay? We're going to let Chris redeem himself. Are you sure, Chris? I'm nervous for you. What do you got? Nice. -3 times -2 is definitely +6. And then when I add them, I get -5, which is correct. Yeah. Okay. Awesome. Last one. Hunter?
6 and -2.
6 times -2 is definitely -12. 6 plus a -2, yeah, that does equal 4. Sweet.
I got one for you.
The second one?
What times what equals 100, then adds to 99?
That's impossible. To -100?
I don't know.
I know, that's why I'm correcting you. All right, so there's that. Let's take a look at your homework because we had a little bit of an issue there on some of things. So let's fill it in together. Anyone feeling bold? Want to tell me what the vertex is? Quinn? Okay. Now my next question, how do you know that?
Because -9 is the lowest point on the parabola. And there's only one of it.
Okay.
It's also when it's starting to repeat itself right after.
Nice. Okay, I kind of like all those things. So if you look at what Quinn's saying, he's saying, well, of the y values, right, or these f of x, since we're starting to use this, it's the lowest number, right? So you can maybe try and kind of picture the parabola. It looks like this. And we know the vertex is usually the lowest. And also, the other thing I really like that he said there's only one of them. All the other numbers are kind of paired. Like there's 2 7s, 2 0s, 2 -5, 2 -8. And then the last thing that Quinn said that was really good was that it's when it starts to repeat itself. Right? And if you think about it on the graph, it's when it starts to come down and right where it turns to start repeating the other half, that's going to be your vertex. There's another piece, though, that how else could we know? This is a specific word. What's the special, where is the vertex in the middle, right? So this is right in the middle of the parabola. And we can see that too on the table, is that it's the same, stuff's the same on both sides of it. The vertex is right in the middle. Okay, awesome. Anyone can tell me the roots? Or do you have a question?
The answer.
Okay, Moises. Okay, Hunter.
-4 and 0 and 2 and 0.
Okay, for sure the roots are here. Now again though, how are you getting that?
Because y is 0. Because
Nice. When y equals 0, right? When y is 0, and we know this is kind of the same thing as y, those are the roots. So the roots here, I'm going to write them as ordered pairs, -4, 0, and 2, 0. To help remind me of the idea right here, that it's when the y value is 0. Right here, when it's 0, those are my roots. Let's skip line of symmetry because they're kind of related. So if the roots happen when y equals 0, how do I tell the y-intercept?
when x is 0.
Yeah, opposite, when x is 0. Okay, so if I'm looking here, the y-intercept now, different, when x is 0, which if I'm looking on my table is where? Yeah, Claudia. 0, -8. And maybe the hardest one, I don't know. Maybe the easiest one, depending how we think about it. Nope, someone I haven't heard from. Line of symmetry. Yeah? Nice. How you getting that, Luis? Okay, the line that goes straight through the middle, and if we kind of try and visualize it, right, we know a parabola goes up and down, that the line of symmetry is going to be straight through the middle. And when we're talking about that middle, we're talking about the x coordinate of the vertex. Okay. Because on a graph, right, do you agree that it's this line? Okay, so let's look at a graph of it real fast. Right. If we look at it on a graph, talking about this equation, a straight up and down equation. Okay, if that's our, let's say that's our x-axis and this is our y-axis. And let's pretend just to talk about it, that our line of symmetry is right here. Okay. 2, 4, 5, 1, 2, 3, 4, 5, 2, 4. So I'm giving you guys some points. What's this ordered pair right here? What point is that? Nope, I'm just putting points on this line. Okay, what's this one? 4, 1. What's this one? -3. What's this one? What's the same on all of these? Look, what's the same? What's all it for? The x, right? The x on these is all 4 because this is the line x equals 4. Okay. We could do the same thing with horizontal lines. Horizontal lines are y equals because the y's would all be the same. Okay, great. So that's just to kind of start understanding some of our parabola stuff. Today we are looking at a new form. We haven't really seen them that looks like this. It kind of looks like those problems from our homework though. What I would like you guys to do, we've talked about plugging these in the calculator, right?
Yeah.
Okay. How do I fill this in? Yeah, put -2 for x. A quick way to do it, and the way I would like you to practice, is plugging it in the calculator. So squared -4. And when I press enter, I get 21. What? Okay. And the other next way to do it is if I press second enter, right? If I press second enter, it brings what I already said, and I can go back And then I can type that to a 1. And then I can keep going with this whole thing. Okay. So that's a quick way to do it. The important piece that I really want you to have in the next 6 minutes is this piece right here. Okay? This here is the piece that I really want. Okay? So, take 6 minutes. I think we are all definitely at least here. Got this piece. Does it? The vertex is 3 too. Okay, looking at these again, you should have came out with your vertex. Does anyone want to tell me? Want me to write it? What do you want to do?
-4.
Okay, thanks, Moises.
See, kind of.
The roots,
0, 5, and 5, 0.
well,
1, 0, and 5.
Oh, 1, 0.
there we go. 1, 0, 5, 0. Y-intercept, that's where you're, 0, 5. Jose's on a roll.
0, 5.
0, 5, that piece.
X equals 3.
Is that-
X equals 45.
What?
No, don't ruin your roll. X equals -3. Not negative 3. Not negative 3.
Regular? Okay, our line of symmetry right there. X equals 3. Okay, now here's what I'm saying. Let's check. I love doing this. I love doing this. Just look, look, look. Okay. What numbers are in the equation?
-3 squared.
Okay, there's a -3. We're gonna ignore the squared. Ignore that.
There's a -4. It's basically.
Okay, so we got in your head, -3, -4, -3, -4, -3, -4. Are they in our heads? Do we see them? Are they big enough? Not for Manuel. He said he couldn't quite see. -3, -4. Okay,
I can see now.
where are they?
There's no -3 on there. It says
It's -3 and then -4.
Okay.
It tells you the vertex.
Okay, if we kind of just ignore that, like, it's kind of the vertex. Like, there's the vertex.
but it's not negative.
Something a little weird. I don't know. Okay. So it tells us, it seems like, and this is just the first one, so not totally sure, because that's a little bit weird. It's not a clean fit, but it seems like it's kind of the vertex, at least the numbers match, even though it's the wrong value, right? It went from negative to positive. Take 30 seconds in whatever way you'd like to say that to write a sentence. The equation tells us the what? And don't say, you can't totally say vertex, like you may need to add to that. Okay? Take
Negative, count to 2.
to what, how high?
3.
16, right?
Oh, 15.
So look, if we look at our normal window only goes to 10, right? It only goes to 10. So if I go to window and I go to y max, because we're talking about the y-axis needs to go to more than 10, we need to go higher than 10. So if we go to 20 and I graph it, now I can see my vertex. And are you going to calculate a maximum or a minimum right here? Cool. Everyone needs to calculate a maximum, because calculating a vertex is going to be a big skill in here. Well, did you calculate it? Did you? You don't even have it typed in. Type it in there. And you still haven't done this? Make sure you have your equation typed in.
I have.
Just hurry up.
I have.
Okay?
Put the minus.
Okay, put the minus. On your graph, I'm going to talk about the vertex one more time. Second, calculate. We are going for a maximum because our graph is upside down. Does anyone know why our graph's upside down?
My graph was bigger.
It might. Like the other graphs are going like this. Yeah. This negative sign makes it sad. Okay.
Oh yeah.
To find the vertex, did you get it yet?
I just
No, you
figured out.
didn't. You don't know the vertex though.
I got you.
Ask you to go to the left of the vertex. So make sure your blinker cursor is to the left. Hit enter. Go to the right. Go to the right of the vertex. Hit enter. You don't need to worry about guessing. You just hit enter again. And then it tells you.
Good. The vertex is going to be 2 and 16.
Yeah, so if you get 2 point something, or if it's really close.
Oh my God, what'd you do?
No, you didn't. It's 2, 16. Does this fit our pattern?
Yeah.
So look. Here is our pattern. Here. The 2, this part is opposite. If you guys think, is everyone thinking that you're ready to be done? Because you are only done if you can graph this without a calculator.
It says.
Watch me. Not
Okay, this is when we're done. Is everyone ready for that? Or no? No?
You put like,
Dominic, do you know the vertex of that? No idea? Do you have some idea? Sit down, please.
out with calculator.
Okay, without a calculator.
Oh, that one.
Here, we should be able to say, okay, great, the vertex is -3, -7. We should be able to get that part. What's your question, Gopal?
So, like, I guess that we can find the vertex without the
Mhm.
calculator. Like, how would we be able to find like the other?
Nice, perfect question. We've graphed enough parabolas. Let's check this out. Okay, I know where the vertex is, but how do I know the other stuff? Okay, we know it's the same on both sides. Yes?
Yeah.
Okay, from the vertex to the first point is how far? 1. From that point to the next point is how many?
3.
And from that point to the next is how many?
1/4.
Nope, just up. How far does it go up? Who is saying 4?
5.
Okay. Then how far is this?
7.
So what's the pattern here? What would the next one be? 9.
Up by every other number. 9.
Okay. So it's going up by 1, 3, 5, 7. It's going up by 2. And here's why. You should not be looking that way. Okay? Here's why. Let's look at this. There's 2 patterns going on here. This was from each point to the next point. But if we look at from the vertex to the first point is how far? 1. And if I go from the vertex, how high up is the next point?
4.
And from the vertex to the next point is how many?
No.
9.
9.
9. And from the vertex to the next point, how many is that one? I'll give you a hint. This is up.
15.
This is up at 7.
15.
No.
14.
7 and 9.
16.
16.
10.
Does anyone know the next number?
2.
2. Where'd you get that from? The little one.
1, 4, 9, 16, 25? What? Yes, it's 25. What's the next one? 36.
Because you add 2 and then you add the last one, right?
There's an even quicker way to do it. What makes it? Does anyone know what makes a quadratic equation? The squaring. Oh, Chris, you're good today. The squaring. If I move 1 away, what's 1 squared?
1.
If I move 2 away, what's 2 squared?
4.
3 squared?
9.
4 squared?
16.
5 squared?
25.
Right?
We should have
36.
We should have a square off.
49.
Okay.
See who can square the most.
Let's do it. Okay.
56, 49.
One day.
And
Not
then
just
54.
64.
And then 81.
81.
And then 100.
Yes. Then what?
And then 100.
Okay.
121.
Nice.
And
So
then-
look. Here, okay. Okay. This in blue is like what makes a quadratic function. This idea of squaring numbers, that's what makes a parabola. Now the easier pattern for graphing, and I think Charlie, you were already noticing this, what's the distance, if really we start at 0 for the vertex, what's the distance between 0 and 1? Between 1 and 4? Between 4 and 9?
5.
Keep going.
Oh, 7.
And then,
12.
don't be crazy. Okay. These are the same, right? The distance between the square numbers is this pink pattern. The square numbers are the blue pattern.
There's too much math in one day. I can't handle it.
Okay. Okay. So, to go back to Gopal's question, if we know where the vertex is, we can use this whole square number pattern to get the rest of the points on our graph. So going back to here, if we know that that's the vertex, we can put the vertex on there and go 1, 3, 5, 7, 9, blah, blah, blah. Okay. So let's all do that. Let's go to your notes. So we kind of just discovered a lot of stuff. Let's just put this form has a name. It's going to be shocking. I don't want you guys to get too scared. Okay, it's called the vertex form. I didn't tell you this at the beginning, for obvious reasons, I think. If you're not making the connection, I am concerned. Yeah, okay. The vertex form of a parabola tells you the vertex. So if my equation looks something like this, for some odd reason they use this h and k. We don't really need to worry about it. Okay. If this is your equation where you have some numbers for h and some numbers for k, let's again think about it one more time. If my equation says negative h, what's my actual vertex? Positive h, and what happens to the k?
No, it exit out. No.
Go back to it.
It doesn't. It combines.
Positive 5, negative 9.
They stay the same.
Negative 5, negative 9. Okay, notice the negative 9 for sure stayed the same. So k is going to stay the same. Whatever numbers those are, that tells you the vertex. Vertex form tells you the vertex. Okay.
Is it a fact?
It's a fact. So the one example we want to have is if I did want to graph by hand without using a calculator, and we're going to go back to our original equation. I want you guys to go ahead and try and graph that. Combine that knowledge of knowing where the vertex is and that pattern we just looked at so you can graph this by hand. Okay. So take, all of a minute. If you're not sure still how to graph it, fine. At least make some axes on your paper because you're going to need those. Sure we are all good?
Is there ever an equation that sort of just makes an
Yeah.
Use into like an oval.
Are you talking about something that looks like it would look like parabola,
And then it goes
but then like that?
Yeah.
Yeah, that's an ellipse.
Ellipse.
Yep, ellipse. You guys have learned, a lot of you guys, if you've learned circles before, like x squared plus y squared equals r squared,
Oh yeah.
and you had to move a circle, blah, blah. It's similar. That's fine. Okay. Good. I don't know what I'm talking about. I'm blacking out. Okay. We know this is vertex form. Like, you should start to recognize some parentheses, squared, definitely vertex form. Okay? So, and like we already said, and it's just to help call it out again, the vertex here would be, if it's positive 3, going to be negative 3. Negative 7 stays the same. So that my vertex is at negative 3, negative 7. An important part. And you can use either one of these patterns that we talked about. Okay? The pink stuff, the 1, 3, 5, 7, the point-to-point pattern is a little easier to use because you don't have to count as high, right? You don't have to do as big numbers. But I do want to emphasize that the squaring, is the piece that makes it a parabola, right? That's the squaring pattern. This is the pattern where the pink one comes from. So I don't mind if you use the pink one. I just want you to kind of keep in mind why it works. So that when I graph this now, I know that it's the same on both sides. And the distance, you want to go ahead, go again. Cool. The distance from the vertex to the first point goes up 1 on both sides. The next one is 3. And then the next one is 5. We put a flag. Okay? So that here's my parabola going up into my words. And again, if I were you, because we didn't quite put this in our notes, if I were you, I might go ahead and call out my little pattern that it goes 1, 3, 5, so that you have the pattern in your notes when you look back to it. Okay? Awesome. So that's vertex form. That's all there really is to it. Yeah. Once everything is cleaned up, we'll give you your homework.
What do you get off me?
What?